Okay, I'm using my mom's Gmail, so it might be a minute before I actually join the classroom.
Yeah, don't worry about it. Like I said, the main purpose for which I'll be using the classroom for this class is just to make sure that you have the slides and the materials.
Okay.
So even if you don't do it right now, just sometime after the class,
Okay.
it'll be perfectly fine. So a bit of a delay, but don't worry about it. This first day, I guess our biggest goal is to make sure everyone is up to speed and is ready to jump into our CAD 3 class using Onshape. So to introduce myself, my name is Eugene. I'm going to be the instructor for this class. I'm currently in college. I'm a third-year student studying mechanical engineering. So computer-aided design and mechanical design, kind of the two main subjects of this class, is something that I'm really interested in and something that hopefully I can bring some light to you guys. So I see a lot of new faces in the group. I know this is the third class in this series. So even if you haven't taken the first two classes, don't worry, that's perfectly fine. We're going to go through what you need to get you started from basically nothing. And with that, we'll go right into the goals for this class. So for those of you who were in the previous classes, maybe with me, maybe with someone else, the goal is kind of to transition away from just learning the basic fundamentals of how to use Onshape and kind of the stated goal of 3D printing, and moving towards a new goal of kind of applying our knowledge of 3D CAD to a specific goal. In this case, we kind of look at the traditional, typical like middle school or high school robotics competitions as kind of a motivation for why we'd want to study CAD. Over the course of this 8-week class, we're going to be designing together, I guess individually, but with support together, a simple robot in Onshape with the goal of moving something like a ball or another target from one place to another. And along the way, hopefully, you'll learn a little bit about the concepts like simple machines, which will help you understand better how to design things in CAD that would make sense in real life. As you probably saw from the email, this is our class overview. It's going to last 8 weeks, 1-hour session per each week. So every week on Saturday, you'll come to this Zoom call at 6:30 and we'll end at 7:30, and that's how things will go. To break things down, we kind of have these 3 different parts of the class. So in the first 3 weeks, we're going to focus on like a little sub project where we CAD the arm of the robot. In the second section for the next 2 weeks, we'll learn about and we'll design and model the chassis of the robot. And in the final 3 weeks, we'll finish the rest of the assembly and remaining systems of the robot, as well as save the last class to have a kind of like symposium or group sharing activity where you get to see what your classmates have made and have been working on throughout the class. And I think this is really important because a lot of what our goals here as like engineers is to be able to communicate and to show others what you are working on. So it's no pressure. We're all friends here. We're all here for the common goal to learn a little bit about CAD. So there's your bird's eye view of what we'll be doing for the next 8 weeks. In terms of what to expect, every week during the 1-hour session, there'll be a portion where I'm talking at you guys like I am right now. And then after that, there will be some work time where you will individually be working on your CAD in Onshape. And outside of class, there'll be some expectations of some work that I want you to do, just so you can keep your practice up with the CAD, as well as keep up the pace with the projects that we're going to be doing. So at this point, if you have any questions, feel free to ask them. If you ever have a question in the class, you can unmute your microphone and ask it directly. Or if you feel more comfortable, you can always type it in the chat as well. And I will check on that once in a while and try to get to those. And if you don't have any questions, feel free also to share maybe why you're interested in CAD, what you're trying to learn, maybe if you've had any previous experience in CAD. I'll wait until I hear one person reply, just to make sure I'm not in an empty room by myself. You can type in the chat as well. How about you, Christopher? I see you in my Zoom window. Do you have any experience with CAD before? Christopher? Very nice, robotics team. What kind? Is FIRST or Vex Robotics? First FTC, okay. Yeah, I personally did not do robotics myself in high school, in middle school, but it's very cool that you get to be exposed to such a thing, because now that I'm studying like engineering, I really wish I had done those things when I was your age. Cool, so great. I hope that means everyone can hear me. Things are going fine. There are no questions. Perfect. So before we jump right into things, I know some of you, this may be your first class using Onshape. And so if anyone has not used Onshape before, can you please feedback in some way, either type in the chat or speak up? I see a hand being raised. So yeah, so I'll spend a short time making sure everyone can use Onshape. Yeah, I see a couple hands now. So don't worry if you haven't, that's why we're prepared. And the very first part of this is going to be the instructions for how to get Onshape for yourself. So if you are in the classroom already, these set of slides with the instructions are posted there. So if you want to do it on your own pace, you can open the classroom, open up the slides, and the same thing that I'm sharing on my screen, which you can see hopefully. It'll take you through the step-by-step on how to do it. And so I'm logged in right now, but if you go to cad.onshape.com, which I can type in the chat. It'll take you to a page that looks hopefully something like that. And from there, just like creating an account, hopefully, which you've done before for some kind of service, you hit the sign up button. There's a little link at the bottom that says sign up. From there, it'll take you, I guess I can log out and show you what it looks like. So if you're a first-time user, it'll take you to a page that looks like this. What you'll click is the sign up link at the bottom right. And I guess these days the page looks like this. If you scroll down a little bit, you can see there's the Onshape education option in the middle. And you can request the education account. And what you'll click on is for students. Again, this is all in the slides if I'm going too fast, but just to give you something there.
It's education account, right?
Yes, education. One more time, click sign up, Onshape education, request your education account, and for students. And since you all are students, you can just enter the relevant information here. You are a student. school level, probably grade school. I'd be surprised if any of you guys are in college, but if you are, let me know. That'd also be cool. And I won't go through and show you creating another account because I already have one, but in the slides, there's pictures with what to do here. If you're not sure about like the school information, you can also put in this information for like the program. And after that, it'll ask you to verify the email. And then finally, you'll be able to log into Onshape. What I'll say right now, and I'll reiterate later, of course, is if I'm ever going through class and you think I'm going a bit too quickly, a bit too slowly, if you have any feedback of that nature, just let me know during the class. And like tell me like, oh, slow down, or can you repeat that again? And if you just say that, I'll see it and I'll slow down or repeat it again. So don't be afraid to let me know if my pacing isn't quite right. And so if you already have an Onshape account and you're good to go, or if you just successfully created the Onshape account, whenever that happens, please type a message in the chat because I want to make sure that you all are good before I move on. If you have any problems, if you have any questions, also please type in the chat, as having this Onshape account will be rather important for this class and the one to follow. Again, I'll type in the chat as well. And I just want this kind of feedback so I know where everyone is. From my point of view, all I see is my screen and okay. Yeah, thanks for the chat message. So it means at least one person is able to do it. Jeffrey, do you have a question?
Yeah, so the school name and the URL are the same?
If you're using this information, like the school name, you can just call like AOE, or you're also welcome to use your own school if you prefer that. All right, 2 people.
I got it.
Great. Lyndon, do you have a question?
Yeah, it says, what am I using Onshape for? What do I put there?
For that, you can just say that you're using Onshape for a 3D design and 3D printing class, which is this class right now. Jeffrey, do you have another question?
Oh, no. Okay.
Just testing the reactions.
Wasn't trying to.
Leo, do you have a question?
Could you talk slower when you're teaching the lesson, because I'm only 7 years old?
Okay, sorry. Yeah, that's a good point, and thanks for bringing that up. Yes, I will try to talk slower. Yes, to answer your question. Again, as a reminder, once you create the Onshape account, please leave a message in the chat so I know if everyone is fine. Do you have another question, Leo?
Like I only know how to do Scratch, so I don't know if I'm good enough.
Sure. What you'll find is that Onshape is a bit different from Scratch in terms of kind of the goals involved. So I guess while we wait for everyone to create an account, I can kind of go over the difference, perhaps like the high level motivation for what is CAD and why you would want to use CAD. So something like Scratch, which you just mentioned, is what we'd call like a programming language, where we're trying to create a set of instructions for a computer to follow, and it'll execute that code and do something interesting. So in Scratch, you often make something like a simple game where you have sprites that move around and interact with other sprites. There's some similarities to that with something like Onshape, where you're telling a computer a precise set of instructions to tell it what to do. But the difference is that your final goal, I guess maybe not your final goal, but one of your goals with using a CAD program is to create a 3D model. So although having some experience with programming might help you with some of the thought processes involved in CAD, like organizing your feature tree or putting in your inputs like precisely, or I guess at very advanced levels, there is some code that you can have involved with your CAD. But at the level we're going to be learning now, it's a lot more of learning how to use the program, how to interact with the specific software. You're more of a user rather than a creator of a code as you might be. And so continue working on creating your accounts. I know not everyone might be done. And as I said before, please continue to let me know in the chat as soon as you have an account. So far, only 2 people have responded. So as far as I know, most people are not yet having an account created. So don't panic. I'm not going ahead. I'm just continuing to explain kind of the motivation for what you might do with CAD. So from what I've heard, at least one of the students in the class is on a robotics team. Maybe more of you are as well. Maybe some of you are interested in joining one. And so is there a question, Leo?
Oh, that was an old hand.
Mason, do you have a question?
Yes, so I'm trying to help him sign up. How do I sign up for do I just, because when I go to the cad.onshape.com, it doesn't really say, it just says to sign in, not sign up.
So if hopefully you're looking at a page that looks something like this one.
Yes.
Yes, so in the bottom right, it says there's a link here that is sign up.
Uh-huh. Okay, let me try that.
And all of the information in these slides as well is on the Google Classroom. So once you have joined the Google Classroom, you can also look at these materials, which can hopefully provide more help. Upon clicking the sign up link and scrolling down, there's the Onshape education option here in the middle, and you can click request your education account, which will take you to this page. And from this page, you can click for students, which has the fields to input the information. And after that, the account will be created. So as I was saying, for those of you who are on a team, you probably may know about this already. If you aren't, this might be something new. This is a video. This one is FTC of an example of the kind of robots that may be representative of what a student team might build. So this can be middle schoolers, high schoolers. Maybe that's a long way off for some of you, but in general, this is the idea of what students of around your age will use CAD for in a practical setting. And so, as I mentioned at the beginning of the class, one of our goals, one of our projects that we will try to finish over the course of our 8 weeks is to create a simple CAD model that basically covers the important systems of a robot like this one. So we won't go into all of the details or accurate modeling of all of the components and hardware, but as a kind of introduction into assemblies with multiple systems that fit together. This is the image you should maybe have in your head. Again, as a reminder, please let me know in chat once you have created the account. So far, I still only know of 2, Christopher and Leo. And so in the interest of time, I will continue to talk about kind of the project overview and such. This part will not involve the CAD itself, so don't worry if the account is not created yet. But as this class is being recorded and the slides will be posted on the Google Classroom, you'll be able to come back and either watch this recording, hopefully, or look at the slides again on your own time. So again, just in the interest of time, I will continue to talk and move on. But if you do not have the account yet, don't worry too much. Based on like the level of the class and seeing that most of you have not worked with Onshape before, I'll kind of adjust the pacing of the class to make sure that you'll all be okay for the second week. And with that, kind of this is the idea that we have for the project for this class, which is creating a model for a robot similar but simpler, less complicated in scope than the one that you saw in that video or the one that you see here to the right. And in my mind, when I look at something like this, I think of it in terms of multiple different subsystems. So the entire robot is one rather complicated system, but within it, you might have different people who are working on different subsystems, smaller systems that serve a specific purpose to help the entire robot function and complete all of its tasks that it needs to do. So for example, one of these is the chassis or the frame. This is kind of the structural aspect of the robot. This is what the other parts of the robot mount onto so that they are all connected. Here you can see these different like C channels, or you can see these long beams with the patterns of holes in them. These frame members, they provide the structural integrity, the structural object onto which things like the wheels and the other systems are mounted onto. Another system would be something like the drivetrain or the powertrain, which involves the components that allow the robot to move. In this case, the robot moves with wheels. You can see in this example, these are what is called, I believe, mechanism wheels, which allow the robot to move left and right in addition to forward and backwards, effectively replacing a steering, because it would be difficult to create an actual steering system with something like a rack and pinion, which you might have on a car, on a very small system like a robot. So everything What I will refer to when I call it a drivetrain, I'll be referring to everything from the motor to whatever transmission that displaces the power from the motor to where your wheels are. Maybe it provides a reduction in torque, and everything that links up to the wheel, ultimately causing the robot to move. Another system that's very important specifically for this kind of competition application is something like an arm, some system that will allow your robot to interact with the environment, in our case, to pick up a goal and move it around, which is the object of the competition. And finally, this one we will not really go into much here, but it's still very important in terms of a robot, because a robot is fundamentally a combination of a mechanical and an electrical system. So if you're interested in electronics, you probably maybe have worked with something like Arduino and breadboards and wiring, where you have your different sensors, your different actuators, your motors, and your power supplies, and you connect them together so that they can do something useful. So this is how we'll look at the different systems of our simple robot. And for the projects that you'll do, for the CAD that you'll create, we will focus on making our frame, our drivetrain, and our arm, starting with the arm. And so to start off, I'll just introduce a simple concept, maybe not a simple concept, but I'll introduce a concept which will prove useful as we talk about a robot arm. And that is how we describe motion in 3D. So by 3D, what I refer to is 3 dimensions. And maybe in your math class, you have learned about what a spatial dimension is. But simply 3 dimensions just refers to the space that we have in our world to move around. So commonly we refer to them as directions. So we have our up and down direction or dimension. We have our left and right, and we have our forward and backward. So you can think about how you move in the world, and all of the motion that you are physically capable of performing can kind of be broken down into those 3 directions. You can move forward and backward, you can move left and right, you can move up and down, or you can move in some combination of those directions. And using those 3 directions, you can describe all of the motion that you are capable of performing. And so that's what we mean when we say there are 3 dimensions. We mean you can go up and down, left and right, forward and backward. So maybe that concept is not very new to you. You might also see that referred to in your math classes as the X, Y, and Z directions. So if you graphed a graph before, you usually have your X-axis, the horizontal one, and your Y-axis, the vertical one. And so that defines a 2-dimensional space where you can move left and right or up and down. And all of the graphs that you draw on your paper kind of are described by a motion, for example, of a pen on paper. Your pen moves left and right or up and down. And any picture you can draw on the paper, on that 2-dimensional piece of paper, is described just with those 2 directions. So the concept that I'll kind of try to introduce to you is the concept of a degree of freedom. And it's very closely linked to the idea of a dimension, but perhaps is a bit more specific. For a particular object or particular thing, you might be able to describe it in 6 different, what we'll call degrees of freedom. So like I was just saying, any object has the ability to move in 3 dimensions. So that's what we call translation, just moving left and right, moving forward and backward, moving up and down. And each of those is something that we would call a degree of freedom. Another way that you can kind of describe motion is what we will call rotation, which is another concept that you may have experienced before. And what I mean by a rotation is just that it's spinning. So if I have my hand, my camera, which you can hopefully see, in addition to moving my hand back and forth, left and right, up and down, like I've been talking about, I can also rotate my hand. I can like rotate it this way. I can rotate it like this. I can rotate it like this. So technically, even though my hand is not moving left or right, up or down, or forward and backwards, it is still moving. And that is what I mean when I talk about these rotational degrees of freedom. In some contexts, you might see these referred to as roll, pitch, and yaw. For example, if you've ever dealt with like airplanes or spacecraft, you may have heard people talk about the roll of an airplane. Maybe you've heard of doing a barrel roll where the plane is rolling. There's also the pitch and the yaw of the plane. So if that made sense, that's great. If that didn't make too much sense, don't worry about it. It's not that critical for, it's mostly just so I can kind of use this terminology, and it will be pretty useful just in terms of how you think about objects, both in real life and in the CAD and Onshape workspace. So I'll take a little pause here just to give you a little quiz. Again, continue to let me know in the chat if you have successfully created your Onshape account. So far, there are 3 people, Christopher, Leo, and Jeffrey, who I can see have created the account. If anyone else has, let me know in the chat. And if you have a specific problem, let me know and I can try to answer your question. And if you fall into neither of those categories, take a look at this question here. Thinking about what I was just saying about the degrees of freedom. So moving up, moving left, moving forward and backward, turning about each of the different directions. So your roll, your pitch, and your yaw. Think to yourself about how many degrees of freedom are involved in the different objects you see here. So number 1 is a 3D printer. Number 2 is your mouse pointer. And number 3 is this doorknob. Take some time to think, and if you maybe have an answer, type it out in the chat, or at this point, feel free to unmute yourself and say something. All right, I see one response, the door handle is roll and pitch. And so I guess the way I introduced the question is a bit of a trick, because usually these terms roll, pitch, and yaw are defined on a specific coordinate system. So yeah, you're correct that the doorknob has basically 1 rotational degree of freedom. So you could call that roll, we could call that pitch, and we could call that yaw even. Just depends on which way you look at the doorknob. If you're looking at it head on, if you're looking at it left and right, or so on. So if you're looking at it head on, like you're walking towards the door, then conventionally, that's probably the roll. If you're looking at it from the side, like if you're kind of looking into the long end of the door, then that's the pitch as the handle goes kind of like this from your perspective. But yes, there's 1 rotational degree of freedom because the only thing the doorknob can do is rotate, right? Maybe you think the doorknob can move as well, but when we're talking about this context, it's not like you can pull the doorknob forward and backwards away from the door. Like the doorknob doesn't slide left and right or up and down along the door either. And so there's no translational degree of freedom. The doorknob is essentially stuck to the door, but it can rotate. Any ideas for the other two? Right, the mouse pointer I see in the chat has 2 degrees of freedom. If we consider the space that is our computer screen, it's a lot like a piece of paper. It's kind of a flat 2-dimensional space where any object on the screen can just move up and down or left and right. And you might think, oh, it can move diagonally, but a diagonal motion is actually just a combination of moving up and down and left and right. So that's correct. There's 2 degrees of freedom, and there's no rotational degrees of freedom because the computer mouse never does this on your screen. It never flips itself. It never rolls around on your screen. All it does is move in 2 directions translationally. All right. Last object, probably the most mechanically complicated one here. Any takers for the 3D printer? And if you don't want to say how many there are, maybe just start by saying what degrees of freedom it does have. What is a 3D printer able to do in terms of movement? And I know not all of you may have experience with 3D printers, which hopefully you will soon someday. A lot of schools these days are getting 3D printers, so maybe you can look into seeing if you can use your schools. I see an answer from Christopher: up, down, left, right, forward, back. And yes, I would agree with that. If you haven't seen one before, this is how it works. You can see the print nozzle is here. So this little metal bit here, that's where the plastic comes out of. And if you know how a 3D printer works, the nozzle moves around and deposits the plastic onto the stage here. And so when Christopher talks about like the left and right or forward and backwards, that is controlled along these 2 sets of rails. I guess in this printer, the left and right motion is controlled by the printer head moving left and right along these rails. Then the whole thing, the printer head and the rails are able to move up and down along this set of rails here. And then finally, forward and backwards. In this case, the printer's stage, this plate here at the bottom is able to move forwards and backwards along its own set of rails. And with those 3 combined features, ultimately, the head of this printer, the part we care about, the part that deposits the plastic, has 3 translational degrees of freedom because it is able to move up and down, left and right, forward and backwards in space. And that is how it is able to create such a variety of different shapes, because it essentially has completely free movement in 3D space. All right, so with that, a little warm up, hopefully it gets you in the mind to think about CAD and the first project that we'll be working on. So after this first class, I think my goal will be for the first couple of weeks, hopefully by the end of this class, or at least before the start of next class, I want you all to have the Onshape accounts created and for you to try like looking around seeing how to use the Onshape. I will go over a basic example maybe at the end of this class or the start of the next one, so you can get your feet wet, but we will be moving at a brisk pace, so get ready to jump right in. The first project, the first mini project, I guess, of 3 will be the robot arm. So this is the design goal of the robot, where we want to be able to pick up an object, for example, a kind of wobble goal, which is used in a competition. And we will create a 3D model of some kind of arm that could potentially do this. Things to consider are, as you're designing and thinking about what your arm will look like, you need to remember that this arm does not exist by itself. It exists to become a part of the larger robot. So how will the arm attach to the rest of the robot? What parts will it be made out of? You need to make sure that all the components of the arm can be, for example, made by you if you're a part of a student team that's trying to make this robot. And finally, how it's able to move. So going back to the talk about degrees of freedom, your arm will need to be able to articulate enough so that it can cover the sufficient area for you to achieve your goals. So that might be achieved, for example, by having enough joints for the robot arm to be able to reach different places that are nearby and far away from it. And so I'll help you out a little bit here with the brainstorming. This is what I quickly came up with, just as a very simple representation of a robot arm. The little blocks here, the colored ones here, are like servos. So in a real system, you need some kind of motor in order to actuate the parts of your system, right? As you probably know, objects don't move by themselves. They need some kind of power, and that can be done with something like a motor. But don't worry about that yourself. If you want to try it, feel free to model where the motors would need to go. But if that seems like too much for you, just worry about getting the overall components, the actual arm itself. So I expect for this first project, which we'll do over the first 3 weeks of class, and there will be more guidance in the following week and the next week, to create a base, the actual arm itself, the structural members of the arm, and kind of the hand part, the part that will grab your target. So you'll, there'll be some level of independence to the project where you kind of think about and design and then model what you have in mind for each of these components and assemble them together. Most likely during the class, I will also do a demonstration. So if it is perhaps too difficult, then you can follow along with my demonstration. If it's too easy, then you can kind of take some initiative and kind of expand the project to fit your level of what you need to learn or what you're trying to get out of it. So as we approach the end of the class, this is the slide of kind of importance. This is the very first thing that I want us to do together. And that is the base of our arm of our robot. So the objective is just to allow the rest of the arm to be able to mount onto something else, which will be the frame of your robot later on. But for now, it's just a simple object, kind of like a plate with a mounting point for the rest of your robot arm. So some constraints are given here because in real life, you'll always have constraints. I want the whole thing to fit inside of an 8-inch cube. So make sure it's not too big because we don't want it to be unreasonably large. I want you to have a mounting bolt pattern. So when it comes to making things in real life, it needs to attach somehow to other things. And one of the most common ways to do that is using fasteners such as bolts. So if you're perhaps at a higher level where you know a bit about hardware and doing CAD already, then go ahead and do things like model them for the correct clearance size for actual standard bolts. Otherwise, maybe you're more new to CAD. Don't worry about all that. You can just model a simple hole where the bolts should go. You need to have an arm attachment point where the rest of the arm will go. And at that attachment point, just make sure you have a hole which will serve as like your fastener to the rest of the arm. So this is the constraints of the arm of the robot. The original plan was for you to do this kind of like in class and then finish the rest of it as homework. But obviously, as we saw, like every time the class is a little bit different. So this time I'm going to focus a bit more, maybe start off by taking you by the hand a little bit more. So next week, don't worry about starting the CAD unless you really want to. I will do a CAD demonstration at the start of the next class, which will equip you to work on this. The real homework, which I really do need you to get done, is finish creating your Onshape account. Log into it and take a look around. So, and one more thing, Google Classroom. So Google Classroom is, so that's something I'd really like you to do right now before the class ends, just so you have access to the slides, which will help you again later on. The recording, I believe, will be posted by Miss Fee. So I'm not really in charge of that, but you'll see where to look.
Yeah, I will take care of the recording. Thank you.
And the most important thing is to get your Onshape account created so that next week we can really start to get into doing the CAD models and going through the environment, because that's really the main thing we're trying to do here. For those of you who have created your Onshape account, I'll do a very, very quick, just showing you how to get yourself started. And if you don't have the account yet, you can go back and watch the recording. So if you have the account, please log in. And when you log in, it'll take you to a screen that looks something like this, except if it is a brand new account, you will not have the things in the middle here with all of your old projects. It'll just be empty here. But on the sides and at the top, you will see the same thing where it is your account logged in. And on the left, you have kind of these buttons. So those of you who do have the Onshape account, just confirm for me, please, anyone, that you basically see this page here. Maybe not with these, but if you could say in the chat, if you do have the account created. Yeah, I see a thumbs up, so that's good, right? So you see something like this, and what you'll do to get yourself started is in the top left corner, there is a button that says Create. If you click Create, the very first thing you can create is a document. So click that, Create Document, and this dialog will show up. It asks you for a document name, and you can type in a name that you want. And after you enter a name like that, you can press OK, and it will create the document for you. Now this is where it all begins. This is where we really get into the CAD. And what we have here is kind of the Cad Workspace. So here is where your model will show up once you start to create the model. On the left is your feature tree, your history. If you've used a different CAD software before, you might be familiar with some of these things. Onshape is very more or less traditionally the same as any other parametric design software. If you've used something like Inventor, or maybe not Autodesk like Fusion, but if you've used SolidWorks, for example, or something like that, this will come as no surprise to you. Some of these tools may be familiar. I've never used Roblox Studio, but if it is similar, then that's great. Some simple controls here. When you're in your workspace, if you scroll up and down with your mouse wheel, scrolling up is zoom in, scrolling down is zoom out. That's probably pretty familiar to you if you've used a computer. Other things, you can left click on something to select it, and then the way Onshape tells you that you have something selected is by highlighting it in yellow. And you can deselect something just by hitting escape, or well, you can deselect it by clicking on the background, right? So left click is your main interaction button, zooming in, zooming out. Now, if you right click and hold the right click and move your mouse, that will rotate your view. So you can see the planes in my workspace are spinning because I'm holding my right click and moving my mouse around. That's how you kind of rotate around. The third one that's very important is your mouse 3. So on most devices, if you click with your mouse wheel, so if you click here, that's your mouse 3 input. Maybe you have a special mouse or something that has a different M3 button, but whatever is your M3 input. On most standard computer mice, that's the clicking on the mouse wheel. If you hold M3 and you move your mouse, it'll pan your view. So it moves everything in your view. And that's basically how you control yourself. If you ever get lost, if I pan too far away and I get lost and I don't know where my thing is, I can hit F on my keyboard and it will bring me back to home. So again, I pan too far away, I lost everything, I can't see anything at all. If I hit F again, it'll bring me back home. And I know we're over time, but since we had a late start, hopefully none of you have an appointment at 7:40. I'll stay just a couple more minutes. Here in the top right corner, we have a navigation cube. And here you kind of see what I was talking about with the 3 dimensions. We have our X, Y, and Z. And that's almost always how we will talk about 3D objects. When we specify a direction, this way, along this red line is your X-axis. This way, along the blue line, that is your Z-axis. And this way, kind of into and out of the page, is the Y-axis. And that just depends on where I'm looking. The axes stay the same, but they might not always look the same in your view. For example, now Z is this way. If I rotate it again, now Z is this way. But as you play with it yourself, it'll all probably start to make more sense. And finally, one last thing for the intrepid among you. The very first thing that you will do, if you've not used a CAD software before, or if you have, is to create a sketch. So in the very top left, there's a button that says sketch. If you click it, it brings up this dialog. And all you need to know, if you click the sketch button and then you click one of these three planes, front, right, or top, I will click front. Then you can see that your tools have changed. So I won't go too much now because we're already over the time. But for those of you who want to explore, in the meantime, before the next class, I know we did not get to much content today because of both the delay and the fact that most of you were not previous Onshape users. But if you want to start experimenting, Sketch is the place to do it. That is the most fundamental thing to learn. And otherwise, just make sure that you have your Onshape account by next week. This is very important because I will assume at the start of the next class that you have Onshape, and I will begin the class with that assumption. So if you do not have Onshape, you will not be able to do the class. Otherwise, that's all I really have for this first week. I know for those of you maybe who are more experienced, it was perhaps a slow class, but we will pick up, don't worry. And for those of you who are still working on Onshape, don't worry, I will make sure the first few weeks are there to get you up to speed, and we'll have a nice start to our project. So with that, if you have any last questions, feel free to ask me, but that is the end of the class. So you're free to leave, and I'll see you again next week at 6:30.